Good day, everyone. So, this is ECE 27. This is yours truly, Mr. Arabal, BS3C. So, for today's video, we're going to discuss about T flip-flop. So, the T in T flip-flop stands for toggle. When you toggle a light switch, you are changing from one state, on or off, to the another state, off or on. So, we have here the logic symbol for T flip-flop. The J and K is connected together, and we have here an input clock and output of Q and Q prime. So T flip-flop could be a positive or negative edge triggered device. In other words, the inputs will affect the output only when the clock signal changes from low to high for positive or from high to low for negative. However, when an edge applied to the clock input, the flip-flop will hold or latch the last output Q if t is equals to 0 and will toggle it to its complement if t is equals to 1. So in short, t flip-flop uh, stands for toggle or toggle flip-flop. So we have here the logic circuit. So we have here uh, 4 NAND gates. We have here our t uh, connected to another NAND gate, and we have here output of Q and output of Q prime, where one input of NAND gate is fed directly to one output of our another NAND gate. So we have here clock. So this is synchronous. So next, operation of T flip-flop. So the next state of the T flip-flop is similar to the current state when the T input is set to 0. So if toggle input is set to 0 and the present is also 0, the next state will be 0. If toggle input is set to 0 and the present is 1, the next state will be 1. So the next state of the T flip-flop is opposite to the current state when the T input is set to 1. So if toggle input is set to 1 and the present is also 0, the next state will be 1. And if toggle input is set to 1 and the present is also 1, the next state will be 0. So this is the operation of a T flip-flop. So we have here our truth table of T flip-flop. So if our clock, we have here our clock, our T, our Q, and Q prime. So if our clock is equals to 0, our T is don't care state. So our Q and Q prime is latch. So if our clock is 1, our T is 0, same. So we have here Q and Q prime is latch. So if our clock is 1 and our T is 1, so our Q and Q prime is toggle. So we have here our next state. So if our clock is 0 and our T or toggle is don't care state, so we have here our Qn plus 1 is equals to Qn. So if our clock is 1 and our T is 0, our Qn plus 1 is equals to Qn. And if our clock is 1 and our toggle or T is equals to 1, our Qn plus 1 is equals to Qn prime or Qn bar. So we have here our characteristic table. So we have here Qn, our T, and our Qn plus 1. So if our Qn is equals to 0 and our T or toggle is equals to 0, our Qn plus 1 is equals to 0. If our Qn is equals to 0 and our T is 1, our Qn plus 1 is equals to 1. So if our Qn is 1, our T is 0, Qn plus 1 is equals to 1. And if our Qn is 1, our T is equals to 1, our Qn plus 1 is equals to 0. So based on this characteristic table, in short, our Qn plus 1 is equals to Qn XOR T. So this is the summation of characteristic table. So Qn plus 1 is equals to Qn XOR T. So we have here the excitation table Qn, or this is Qn plus 1. So this is Qn plus 1 and T. So if our Qn is equals to 0, our Qn plus 1 is 0, our T is 0. So if our Qn is 0, our Qn plus 1 is 1, our T is 1. If our Qn is 1, our Qn plus 1 is equals to 0, our T or toggle is equals to 1. And so we have Qn of 1, Qn plus 1 of 1, our toggle is equals to 0. So in summation of this excitation table, T is equals to Qn XOR Qn plus 1. So we have here our simulation of our EWB, electronic workbench of our T flip-flop. So if our so we have here 4 NAND gates, our toggle, our T, and our clock. So if our T is 0 and our clock is equals to 1, so our T flip-flop is latch. So if our clock is equals to 0 and our T is equals to 1, so our T is equals to 1, our flip-flop is latch. So if our T is equals to 1 and our clock is equals to 1, so we have here our flip-flop is toggled. So this is the simulation of our T flip-flop. So in summary, our T flip-flop means toggle flip-flop. It means output will change with respect with the input along with the clock signal. So that's all for our discussion of T flip-flop. So goodbye and thank you.